All right, guys, let's start. Let me share the screen. You guys can all hear me? Cool. All right, so welcome to the American Computer Science League. And oh wait, hold on. This is the wrong thing. One second. Never mind, it's the right one. So, one sec. All right, so today we're gonna be going over the ACSL American Computer Science League, just like stuff that they would test you. And so, like in high school, there's just a competition that our club participates in. There's a senior and intermediate division, and so yeah. So the homework was to build a calculator that takes your birth year and inputs and outputs your age in years. It's pretty simple. Um, Yeah, I don't we're not gonna go over that, I think. So oh, this was last week's? Okay. Wait, April. Okay. Alright, it's fine. But we didn't review ACSL, right? Alright, great. Alright, it's fine. We'll just skip the homework for today then. Alright. So this is gonna be like competitive computer science. It's fine, guys. Alright. So let's go over that. So what exactly is ACSL? The American Computer Science League. It's gonna be an international competition and it's split into five divisions. Yeah, just for today, no homework. Yeah, it's split into the elementary, classroom, junior, intermediate, and senior. But like I said earlier, we're gonna be focusing on intermediate and senior because that's what we do in high school. And anywho, the topics that ACSL include are gonna be what does this program do, which is just like evaluating pseudocode, digital electronics. Are you guys sure you did this? Because the calendar says this is what we're doing for June 24th. Yeah, I think that was USACO. Yeah, yeah. So yeah, don't worry about it, guys. So, anyways, back to us. So it goes over digital electronics, Boolean algebra, computer numbering systems, which are just like different bases, recursive functions, data structures, Lisp, FSAs, bit string flicking, and all that good stuff. And basically, this competition it's structured in four different contests. Each contest has a short problems, which is testing the listed topics here, and it also has a programming section where you have to solve a programming problem, and you have to like meet the test cases for it, kind of like USACO. So contest one, this is gonna be the first contest of four, like I mentioned earlier. And in the short problem section, like where it tests you on topics, it tests you on computer number systems, which is a fancy way to say number bases in like base conversion, recursive functions, and then what does this program do, which is just like evaluating code. So if you don't know what any of that is, don't worry about it because we're gonna go over it now. All right. So first, computer number systems, or like simple bases. I don't know if you guys know about that. You can let me know in the chat. But pretty much the really important number base that we deal with in computer science is binary. Yeah, that's right. So as you guys know, computers store their data in ones and zeros, which is binary, and that's also called base 2. We humans write numbers in base 10 because we have 10 fingers, and that's just kind of how our human civilization started, hence the name base 10. And then, yeah, binary is base 2 because there's only 0 and 1. All right, so how do we convert between bases? So this is actually more like mathematics. If you guys do competitive math like um, AMC, Amy, you'll have some experience with this. But let's say I have a number 1011 in base 2, okay? And the small little number here is going to denote the base. And let's say I want to convert that into base 10. So what I have to do is I'm going to have to count the number of places of each digit. So let's deal with this one here first. Do you guys see my mouse cursor, by the way? Yeah, so 0, 1, 2, 3. Oh, you guys don't? Okay, fine. But basically, this number here, 1011, it's 4 digits long, right? So 4 minus 1 is 3. So we'll start with that. So we'll take 2 to the power of 3 times the digit here, and then we'll add that to 0 times the 2 to the power of 2 because that's going to be the third digit. Then we do, yeah, it is pretty easy, yeah. And then we'll do 2 to the power of 1 times 1, and then so on and so forth. We get 11. So that's how you convert it. Any questions on that? You guys good? Kevin, what's your question? Oh, okay. All right, so no questions, right? All right, so next we're going to go into recursion, and this is also a math topic pretty much. Uh, who here knows about recursive functions? Have they worked with them in AMC, Amy, that stuff? Joel, okay, nice. All right, so basically, recursion is just going to be the repeated process of a procedure or definition, and we're going to be using recursion with programming and math. Okay, exactly, Arif. It's when a function calls itself. So like f of x. So here's an example of a recursive function. Uh, See this if n equals 1, then it's going to return a 1. That's going to be called our base case. And we need a base case in recursive functions so it doesn't go on infinitely. Some of you guys have programming experience, and you guys might know like an infinite while loop. It's kind of like that. We need a base case so it's finite. And these are just other conditionals. All right, so recursion in programming. I saw some of you guys mention the Fibonacci sequence. That's a really good example of it. Uh, Factorials, you can also write that in programming with recursion. And so here we can see that this is a C++ version of this given function here. Uh, so as you can see, if n equals 0, we have that here. It's going to return f of n minus 3, um, and so forth. So yeah, any questions on recursion? Did I go fast? Just let me know. Are we good? Just thumbs up if you're good. All right, great. Awesome. So now we're going to do what does this program do? So yeah, so what does this program do? So basically in this section, what ACSL does is that it kind of has its own pseudocode, which is kind of similar to Python. And what this is testing you on is basically like, can you read pseudocode? Who knows what pseudocode is? You can unmute if you want, but all right, it's fine. So pseudocode is basically like obviously yeah, it's fake code. It's like instead of writing the whole thing, you just write like the very basics of it. So if I wanted to write an algorithm to do factorials, like from the last example, instead of actually writing the algorithm, I would kind of sloppily write it like, yeah, I wouldn't write it like syntactically with the language I'm working in. Yeah. So, like I said earlier, this is a made up ACSL language and it's pseudocode. And basically, you just have to imagine that it would work like regular code, very similar to Python. So, if you know Python, then great. And yeah, any questions? And these could be questions about how ACSL tests them too. It doesn't just have to be on the concept. Are you guys good? Why do they use pseudocode? So, like in the real world, like programmers, right? When they want to just discuss ideas of how they would implement something into like a code or a program, instead of writing the whole thing, which can be like really time consuming, they just write pseudocode, which is just like a very, very simplified version of the actual code in order to like demonstrate like implementation of certain ideas. Does that kind of make sense? It's just easier, basically. Great. Any more questions? All right. We'll go to contest number two. So, context number two, it's going to be talking about prefix, infix, postfix notation, bit string flicking, and Lisp. And let's dive in. So, these are just different ways to kind of express mathematical equations. Uh, yeah, so these words are kind of weird. Like when I was learning them freshman year, I didn't know what prefix and postfix were, but infix is like your normal mathematical expression, like one plus one, two plus two. And then postfix is where all the operations are moved after the operands. So, like, for example, in infix, we would write 1 plus 1, but in postfix, we would write 1, 1 plus. And prefix, like the name suggests, the actual like mathematical operator, it's going to come before the numbers. So, like plus 1, 1. So, how do we convert between different postfix, infix, prefix notations? So, let's say I have a minus b plus c. I want to convert that into prefix. What I have to do is I'm gonna have to like keep in mind PEMDAS and also the operands, which are gonna be A and B, and the operators. So the reason this would be A minus B plus C and postfix would be this is because oh wait, hold on. This is actually wrong because they forgot to write C, but I'll go over the prefix part. So what this technique is called scanning. And so first they looked at the parentheses because PEMDAS, and they converted that into prefix. So A minus B becomes minus AB. Then they looked at minus AB as one part of it, and then C as the second part, and then they converted that into prefix as well. But they forgot the C, which is fine. But yeah. All right. So any questions? How do you know which sign comes first if there are multiple symbols? Oh, like, are you are you talking about, converting infix to other prefix and postfix? You can unmute and just say, "Yeah." Okay, yeah. So, basically, that's kinda tricky, right? But you know how in regular mathematical, like, equations, we follow PEMDAS in order to evaluate? Like, we look at the parentheses first, then exponentiation. Yeah. It's the same thing. We're gonna have to look at each equation in the same order. So, like for example, in a minus b plus. So, do you kind of get it? All right, great. Does anybody else have any other questions? We're good. All right, great. So next, we're going to be talking about bit string flicking, which is just going to be dealing with binary numbers. And so, what is bit string flicking? it's gonna be strings of binary numbers, so ones and zeros, and we're gonna be manipulating them for just uh we're just gonna be manipulating them. And then there are a couple of operators in bit string flicking, and that's how we change the strings. We use these operators, we manipulate them, and such. So these operators include parentheses, the not symbol, the circ, and XOR or. And don't worry if you don't know what all of those are just yet, because we're gonna be talking about them later. So yeah, so first, what is XOR? Basically, that stands for exclusive OR. And you know how in OR is gonna evaluate to true if at least one of the things is true. So when I say this, I'll use an example. If I'm dealing with A or B, that's gonna evaluate to true if if A and B are true, if only A is true, or if only B is true. But with exclusive OR, it's gonna evaluate to false if both of them are true. That's the only thing. Next, we're going to be talking about shift and circ. So, as their name indicates, the shift operator is just going to be shifting the bits around in a bit string. The direction in which they shift is going to be, as well as how many positions they shift over. So, like, let me go back to this slide here. Like, if one of the operators is L shift one, that means I'm going to be shifting this whole thing by 1 unit to the left. So, I push the one out of the way and I replace the empty spot at the end with a zero. Okay. And then circ, instead of just shifting the digit off and replacing it with a zero at the end, circ is actually going to it's literally just going to take the number of digits and circle it in the direction that it says. So, like, our circle is going to take how many digits X at the R, it's literally just gonna take it to the other side. Same with left circle. So any questions with that? This one's kind of complicated, so why would you need circ? Uh oh, in real life? So pretty much, obviously, like I said earlier, computers deal with all their data in binary, and a lot of these programs they manipulate that data, right? Like sometimes we need to find um a certain value within an algorithm and whatnot. And so it's much faster to just deal with the data in binary by like manipulating it like that. Uh, and circle is just like it's just a way to manipulate it. It's not like there's not a specific reason. Okay, cool. Now we're gonna be talking about Lisp, which stands for it's basically a language that processes different lists and stuff, kind of like the name suggests. And we're gonna be getting into car and cutter and stuff like that. That's how you pronounce them, by the way. So syntax wise, everything in Lisp is gonna be an atom or a list, okay? And an element can't be both unless it's nil. And nil is basically gonna be similar to like null in Java. And it's also gonna be denoted as a parentheses. Atoms, on the other hand, are gonna be identified by an apostrophe mark. So like this, for example, is going to be a list with, but an atom is inside the list. Okay. So like hello is going to be an atom. And lists are denoted as elements inside a pair of parentheses. And then just make sure to know that atoms are not to be evaluated. And what I mean by that is like mathematical expressions can be atoms. So like one plus one. And so, yeah. All right, so some more complex stuff. It's not that complex, but basically, we also have functions in Lisp. Anybody with programming experience, you guys have worked with functions before, and so the two functions that initialize variables are going to be set and setq. Set will put a value into an atom. So, like the atom A now has the value 3, and then setq removes the process of having to start the variable with an apostrophe. So set Q A3, and we just assume that A is an atom. And now the other functions that we're going to be working with that I mentioned earlier, such as car and cutter, these guys work with lists. Car is going to take in an argument that has to. What do you mean by an atom? Oh, I know the name Atom is kind of misleading, but pretty much in Lisp, there are gonna be 2 forms of data. So you know how in, like, your normal programming languages, you have, like, integers, doubles, strings? In Lisp, it's only gonna be an atom, which is just gonna be, like, anything marked by an apostrophe. Do you see it right here? Or it'll be a list, which will be anything denoted with a parentheses. Does that make sense, guys? Alright, great. So good. So sorry about that. So yeah, like I said, car is gonna take in a list and it's gonna return the first atom in that list. And then cutter, which is just gonna be the first like element, and then cutter is gonna take in a list argument and return the entire list without its first element. So an example down here is gonna be car. This is a list, okay? And it's gonna return this because that's gonna be the first thing inside the list. Does that make sense? Oh, and by the way, car and cutter are usually used like in tangent with each other and they're combined as well. So like for example, this is cadarder. It's like a very complex word, right? But I'll show you how to like car and cutter are gonna be functions with Lisp. And you know how earlier I said that in Lisp there's an atom and a list like is it's literally a list of atoms. Car is going to return the first element in a list, and then cutter does the opposite. It returns the entire list, but without its first element. So let me type that in chat so you guys have like something to look at. Okay. So yeah, and then with these combined car and cutter like notations, what you do is that you start with the last two like this. So it'll go like this: cutter, car, cutter, cutter, car. You just have to kind of start from right to left. Yeah. Any questions? I know this one is kind of hard. So yeah. So kadar, like that really like complicated like word. It's just gonna be the combination of like a lot of cutters and cars. So like, let me type it in chat. Like with so like you said, what is kadar, right? So you first do CDR, then you first do CAR, then CDR, then CDR, then CAR. See that in chat? Again, you guys start left to right with these, sorry, right to left with these complicated, like, notations. Are you guys good with that? Shouldn't car and cutter be cadar? No, so, like, how this, like, complicated stuff works, it's kinda like a sandwich, I like to think of it like that. Like, car and cutter, they all start with a C, right? So then the first thing will be a C, and we'll grab the last 2 letters from the, end of the thing. So, like, with this, for example, CADDAADR, we first start with CDR because that's at the end, right? Then we do CAR, then CDR, and then we end with CAR. What's the difference between Gadar and CADD? Oh, Suntray. The difference between that is that the second one, you do cutter first and then do the rest that you would do in the first one. Yeah, exactly. You delete a AD every time. Yeah, right to left for the list. Keon. All right, is everyone good? Especially Joel and Elaine, who asked. All right, great. So next we'll do some practice because obviously, like I threw a lot of stuff at you guys without um, kind of making sure you guys understood the concept. So that's what we're gonna do now. So let's do this first problem. What would the prefix expression of this evaluate to? And I'll do a little review. Prefix is gonna be like the operator comes before the operands, and start with whatever operator is closest to the number. So, like for example, here in this example, you would start with plus 99 and times 36. So make sure just type it in chat. Elaine's right. Don't worry, guys. I'll explain it. But yep. Wait, Baron. Uh, is there any question you have that I can like clear up for you? Just type it in chat if you need. No? Okay. Yeah, it is 0 though, and, just raise your hand if you don't know how to get there. I'll explain it. Alright, alright, I got you guys. So, plus 99 times 3 6, okay? So, I think a little thing that's misleading about this problem is that it doesn't have spaces, so you don't know if it's 99 or 36, but yeah, it's gonna be single digits. So first, we're gonna do 9 plus 9 because that's directly before the numbers, right? That's how we do in prefix. We have to check the numbers first, okay? So that becomes 9 plus 9, and then 3 times 6. And I'm typing in chat, by the way, so you guys can see what I'm doing. Oops, I meant to do 18, not 36. And then because we have a subtraction in front of the 18 and 18, that means 18 minus 18, and that's 0. All right, you guys understand it? Who who doesn't understand still? I wanna make sure we all do. You understand it, Lan, or you don't? Okay, yeah. Let me just write the entire explanation. How do you know what order the signs go? Um, so this technique is called scanning, but you have to look at the operator that's directly in front of the number. Oh, yeah, Soham. That's just a problem with like how this like the slides are made, I think. Like usually they'll put a space in between, so don't worry about that. But how do you know which order the signs go? Basically, you're gonna have numbers, right? You have to look for prefix, you have to look at the operator that's directly in front of it. And then for postfix, you have to look at the operator that's directly after it. And then you do like PEMDAS. So like for example, the reason you would do 9 plus 9 first and 3 times 6 first is because the plus is directly in front of the 9, the times is directly in front of the 3 and 6. Does that kind of make sense, Sunshrey? All right, great. We ready to go to the next one? Cool. All right, let's go. This is gonna be a bit string flicking question. Um, and let me explain kinda I don't think I did a good job at explaining, this RC and RS stuff, but pretty much, uh, the first letter is gonna denote the, direction in which you do it. So, like, R, I'm gonna start the right-hand side, and then 1 is gonna denote, like, how many digits I'm gonna, like, scoop up. So, like, 1, for example. So then I go to the first digit to the right, and I circle it over to the left, okay? And then RS1, this is gonna be right shift 1. I take my number and I shift it 1 to the right, and then the empty place here, I'll fill in with a 0. And then not, it reverses each digit. So, you guys can answer this one. Not means just, it's just the opposite of the digits. So, like, 0 turns into 1, 1 turns into 0. So, yeah. So I'll just give a little bit more time to solve the problem, and I'll explain how to do it. So how you do right shift is that you literally take all the digits, you shift it one way to the right, and so the following digit, like at the end, you literally like forget about it, and then the empty place, like at the start of the number, you fill it in with a 0. Yeah. Our circ means that you're gonna circle the last digit to the right, and you're gonna take it to the start. Make sense? All right, guys. So let me put it in chat the solution. The answer should be 10011, and I just showed how to do it too. Let me know if you guys have any questions on that. Do you guys kind of understand how that question goes though? Like, okay, you guys do understand. All right, great. Were there any other questions on the material I covered? Uh, maybe I went too fast on something. Any questions is good. Know how many digits? How do you know? Okay, so how you know how many digits? Wait, Anisha, can you explain a little more on what you mean?
Yeah, like at the end, how many digits are you supposed to have in your answer?
Oh, you will always have 5 digits in your answer no matter what, and a lot of that has to do with the function. So like L circle, R circle, we're always going to maintain the same number of digits because we're literally just taking whatever's at the end or whatever's at the start and we're scooping it the opposite direction, right? And then same with shift, whatever number of digits that like fall off the cliff, I like to think of it like that. Whatever digits like literally like leave the number when we shift it the whatever direction, we fill in the blanks with zeros. Does that kind of make sense?
Yeah.
All right, awesome. Any other questions? Anything's fine, by the way. If you guys don't have any questions, just give me a thumbs up so I move on. We're all good? All right, great. And yeah, don't don't be afraid to ask a question because like this is some complex stuff. All right. All right. So this is gonna be the homework for ACSL, which we're gonna be doing tomorrow as well. And I'll make sure to check that. Yeah, we are doing ACSL tomorrow, so we'll check that this tomorrow as well. And then, oh wait, don't leave yet. Don't leave yet. Don't leave yet. Um, just copy this down, and then we'll go over it tomorrow. Let me know when you guys have it down. Oh, explain number 3 on the homework, you're saying, Soham? Yeah, basically, it's asking you to convert how screenshot. Oh, wait. Basically, it's asking you to convert that number 001111 to base 10. Joe, chill. Yeah, sure. I can explain Qatar again. Okay. So pretty much let me pull it up too. So pretty much like let me put an example in chat real quick. It's like Kadar, right? This is gonna be like a very this is gonna be the combined version with car and cutter, okay? And pretty much how you do it is that no matter what, okay, basically no matter what, the combined form of car and cutter is gonna be in this form. It's gonna start with C, it's gonna end with R, okay? And so in between the C and R is gonna we're gonna have whatever combination of A's and D's, okay? So for example, if I have Kaaddr, we're going to start evaluating this from right to left, okay? So Caaddr, we start with cutter, then we do cutter again, then we do car again, then we do car again. Does that kind of make sense? Mritula? All right, good. Any other questions? Like any last questions? Because we have time and we'll answer it. Do we go from Huckleberry to Apple for Lisp? What do you mean by that? Oh, I haven't done this example, but, like here, let me do it right now. So yeah, Elaine, I think you do. You do go to Huckleberry to Apple for Lisp. Can you explain the base 10 again? Sure. Alright. So, base 10 so, pretty much what base 10 means is that each number that we write in base 10 will have 10 there are only 10 digits you can use for it, which would be 0 to 9. And so we use base 10, for example, right? Like any number we have, we can only use digits 0 to 9, right? Like, there is no 11th digit, true? Do you kinda understand that? And so, pretty much in computer science, for instance, we need to convert all these numbers in different bases. And by the way, if I have a number in base x, numbers in base x only use digits from 0 to x minus 1. So, like, for example, base 2 is going to only use digits 0 to 1 because 2 minus 1 is 1. All right, good. Now, the actual conversion part, let me write in chat too, just to make it a little more clear. 1001 base 2, right? It's gonna have 4 digit. It has 4 digits. A a ones place, a tens place, a hundreds place, and a thousands place, okay? So you start from the left side, and that's gonna be the fourth digit from the left, fourth digit, right? So you do 4 minus 1, and that's gonna be 3. And so then because we're in base 2, you would do 2, that's the base, to the power of correct, Baron, you're getting it. 2 to the power of 3 times 1 because in our original number, 1 is taking up that place. And then you add it to 0, and then you add it to 0 times 2 to time to the power of 2. Sorry, my words. And then so on and so forth. So does that kind of make sense? Or mm, yeah, and I can even start smaller. Can you explain the last part? Elaborate further on that real quick. I'm just typing up some examples so that you guys can also kind of figure it out. And so, like, let me start small too. So, like, suppose I have one base 2, right? In base 10, that's going to be 2 to the power of 0, 0 times 1, which is going to be equal to 1. If I do 11 base 2, that's going to be 2 to the power of 1 times 1 plus 2 to the power of 0 times 1. And that's going to be equal to 3. You guys kind of see the pattern here? Like, the base that we're working within, which is base 2, we put that to the exponent, and the exponent is gonna be the hundredths place, like the the nth place minus 1, okay? So here, let me say. Yeah, so Iro kinda, can you PM someone? No, you can't DM someone here. But basically, the form for conversion but to base 10 is that you're gonna add all of you're gonna add this form, okay? You're gonna do base to the power of the nth place, subtract 1 from that place, and then you're gonna multiply that to the digit in the number, okay? Does that kind of make sense? If it doesn't, just let me know, okay? Okay, it makes sense. All right. Um, all right, awesome. Anybody else with anything? Any questions? Last minute. Because if you guys don't, then we could do a Kahoot to test the knowledge. We're all good, right? Give me a thumbs up. Good. All right. So shout out to April for making this Kahoot. Um, I'm just gonna host it now. Joel, why did you post the answers in chat, bro? All right, guys, just wait a few more minutes. I'm gonna host it. All right, guys, you're gonna have to explain it to me then tomorrow if you guys already have the answers. All right, let me host this Kahoot now. All right, is everyone in? Let's start. Who's that? And that. All right, congratulations to a devious name. Hello, and just like three dots, I guess. Um, all right, we're almost about to end. Are there any like last minute questions, like anything I can answer to like make sure you guys understood the topics? Sorry. All right, no questions, right? Just thumbs up if you're good. All right. Yeah, we'll call it a day for that. Oh, someone has a thumbs down. Miguel, you got a question? No? All right. Um, so like always, we're gonna share the video, share the slides so you guys can review them if you'd like. and we'll see you tomorrow. We're gonna be doing ACSL again, and yeah, you guys can leave. Bye, guys.
Bye. Thank you.